Hi everyone. So I just want to share with you, I got a really excellent message. Let me just pull it up here. Hi, Mr. Jones. Just finished watching the videos you sent and taking my notes, and I'm thinking of possible extension questions. Could there be a situation where you have two logs with two different variables and you would have to create a system of equations to solve them both? What an excellent question. That last part's me responding. What an excellent question that is. So let's think about this. So the question is, could we somehow have a system of equations related to logs? I love it. So um, I'm thinking, well, in a simple form, could we have a system of equations related to exponentials? Yes, of course we could. Let's take this for example. Is that a system of equations? Yeah, sure. It's a fairly simple one because by substitution, we would get 5 to the x minus 1 equals 25 to the x plus 1. Could we solve it? Yes, because 25 is a power with base 5, and 5, of course, is a power with base 5. So this would come right into some of the questions that we did. Let's see here, was it 5.2? Yeah, in 5.2, we did some questions like this, somewhere in here, right? So that would work. And because we can go between exponentials and logs, I could turn this into a log question, right? So I could say, okay, in log form, this is log base 5 of my input to the exponential, my output to the exponential is my input to the log, and my input to the exponential is my output to the log. So I could have, for example, something like this, base 25y equals x plus 1. So there's a system of equations given as logs that we could solve. That is a new question. That is, well, how can I put it? That is not a question that I showed you. Let's put it here on a little chart, but is derived from two different types of questions, both of which you've been showed. So you know this, and so you should be able to put the pieces together and get this. And this is really, really good. The student was thinking, okay, how can I take what he's taught me and sort of combine it or whatever and figure out some other type of question. So that would be nice. And now just to do it, I would start here and I'd go right back to this here, and then from there to here, and then I would solve. So if I was given this question, I'd say, okay, well, I'm going to turn this into exponential form. 5 to the x minus 1 equals y, and 25 to the x plus 1 equals y. This system of equations, by substitution, I can put it this way. 25 is 5 squared, so I can write it this way. And here I have an exponent, well, power to an exponent, and so you can multiply the two exponents. So I have 5 to the x minus 1 equals 5 to the 2 onto x plus 1. The only way for these two powers to be equal is if the exponents are equal. So now I have this. And then that gives me x minus 1 equals 2x plus 2. I can subtract x on both sides. I can subtract 2 on both sides. X equals negative 3. Beautiful. I love it. Could we come up with something here that's harder, like maybe a quadratic? Let's see if I can work backwards and build a system of equations of logs with a quadratic solution. Let's take a quadratic. Well, to make sure the quadratic has solutions, I just take two binomials. Let's suppose those are my binomials, equals 0. So this is basically the solution of x equals 3 and negative 4. and then I'll multiply it together. Minus 3x plus 4x minus 12 equals 0. X squared plus x minus 12 equals 0. There's my quadratic. And now what I would like is to rearrange it so that I have an equation. I can do it however I want. Let's say I'll put the 12 over. What could I do here? Is there anything fancy I could do? I'm not sure. Let's just put it like this. And I haven't planned out what I'm going to write here. I'm literally just kind of thinking out loud, talking out loud, sort of to make it sort of an authentic experience. So you can see how I'm actually sort of thinking through and playing with the math as I go. So now I've got x squared equals 12 minus x. Now I want to turn this into an exponential. I can put any base I want. So let's work with a base of 2. 2 to the x squared equals 2 to the 12 minus x. This is good. Now I can see there's a difference between this one and the one before. The one before we had this 25, which then had, this is frozen here, which then had the 2 applied to the x plus 1. Here, I don't actually have anything squared. If I wanted to do that, this would have to have a common factor. So, I mean, I could finish this off, but actually I'd like to make one with a common factor. Maybe I'll go back and do that. So, common factor question. I'll try that in a second. This here now, I'm going to say each one equals y, so that I have a system of equations. This is interesting with the x squared. Let's see what happens. To be honest, I'm not quite sure what's going to happen. Let's put it into log form. So that's log base 2 of the output is my input. And, oh, I see. I'll just get a squared there. That's interesting. Oh, that is interesting. I could actually make something neat with that. Log base 2 of y is 12 minus x. Okay, so we could make this our question, right? This here could be the question, a system of equations with logs. And then we would have to turn it into exponential form, make them equal, basically go back through this way and end up with our solution right here. I'm also looking at this and I'm thinking, gee, how could I play around with this? And there is actually a way that we could play around with this. It might be just a little bit beyond what you're ready for. But if I square rooted both sides, my right hand side would be x. My left hand side would be that, because anything to the exponent of 1/2 is a square root. Yeah, I'm going to leave that alone. But we could go somewhere with this, I think. Maybe it's a little bit further than where we're at. So I'm going to leave that alone. This is already a nice extension. Let's come back here. I made the comment, if I could have a common factor here, then I could make this base different from being exactly equal to that one. So I'd love to have like a 2 here, for example. A 2. Now this isn't factorable anymore, but could I get a trinomial with a 2 and with an even number here? I'm sure I could. Let's just try a couple. Let's say x plus 4, x minus 2. I'm using even numbers, hoping that that will help. That's an x squared plus 4x minus 2x minus 8. Yes, this is what I want. Plus 2x minus 8. This is what I want, because this now I can make, this is all equal to 0, of course. I say of course because we want this stage so that we actually can solve for an x. this is now 8 minus 2x, like that, and I have a common factor of 2, because it's squared. So I can put it to any base I want. Maybe let's do 3 this time. And because I set it up to have this common factor of 2, I can do this, which then is this. Oh, that's cool. I got another idea. Okay, but one thing at a time. Let's just focus on this one here. This then would be 3 squared to the 4 minus x, right? Because this here would be like 2 times 4 minus x. That's what we have. And so now I have 3 to the x squared equals 9 to the 4 minus x. And then I could make each one equal to y and turn those into logs. I'm going to swoop down here. So I have y equals 3 to the x squared, and I have y equals 9 to the 4 minus x, like that. And now let's put it in log form. I have log base 3 of your output of an exponential is your input of the log, your input of the exponential is your output of the log, and log base 9 of y equals 4 minus x. That's cool, right? So that could be a question right there. Solve this system of equations. And if you solve this system of equations, you would put it into exponential form, and then from exponential, you could then use substitution to make them equal to each other. And then this would become the 3 squared. You would multiply, you'd get this. You could multiply out. You say the only way that this could equal this is if the exponents equal each other, so then you have them. Then you put everything over to one side, equals to 0. And then this, you wouldn't write this middle step, but you'd factor to this, and then you would say, oh, well, x must be negative 4 and 2. That's cool. That's a good question. Could we do anything else? I'm sure we could. Could we change these arguments somehow so that one of them is y and one of them is something else? I'm sure we could. For example, let's take this. I'm going to write it out again. Right? And this is really what I mean about sort of playing around with the math and trying to figure out new questions. It is an extremely effective way of becoming better at math. Not just of predicting what could be on the exam, which is good at that, is good for that too, but it's also a very, very effective way of just getting better at math, because you're not just following one process. You're playing around. It's hard for me to explain better than that. I'd have to think about it. Now, if I wanted to, I could make this, let's suppose I wanted to introduce a 3 here. So I'm multiplying both sides. Let's make it a 9, because I'm looking at my base. Let's multiply both sides by 9. So I haven't changed it, right? This can go to that because I'm multiplying both sides by the same thing. And then this gives me y equals 3 to the x squared. And here I now have 9y equals, and this is the same as 9 to the 1, multiplying, same base, so we add exponents. So now I have 9 to the 5 minus x. You see that? So it's actually the same base problem. This one equals this one equals this one. Okay, so I haven't actually changed, like my solution will be the same. It will still be x equals negative 4 and 2. but I'm making it look different. I'm making it look more sophisticated. So here now, if I put this into log form, I have log base 3 of y equals x squared, and I have log base 9 of 9y equals 5 minus x. See that? The solution to this one here in this red box will be exactly the same as the solution to this one in this red box. But I've made it look a little bit more complicated. This is actually really pretty because there's a property I'm going to teach you, and this second one lends itself very nicely to that property. But I don't want to get too far ahead of myself. I don't want to confuse you guys. Is there anything else I could do? I'm sure that there is. This is really rich ground for coming up with alternative questions and some extensions. I just want to really, I just think it's really good. So I hope that you found something interesting in there, something useful, something helpful. I'll leave it there.